Today is Monday. Not many Mondays left. We are in single-digit Mondays being together.
Yeah.
How many?
Eight left, I think. 8 after this, maybe 9. All right. Last week, we learned that you could take a figure, triangle, trapezoid, any quadrilateral, and you can take that same figure and make it a mirror image of it by flipping it over the y-axis or the x-axis. We learned how to do that. After we take the figure and multiply its x coordinate by -1, we can flip it over the y-axis, or if we multiply the y coordinate by -1, we can flip it over the x-axis. Remember that last week? Today we're going to learn to take a figure and instead of flipping it, making a mirror image, we're just going to slide it around. And in the book on page 409, they call that a translation. Say that word. Okay. Now, most of the time in your life, up until now, you've heard that word translation. You think, oh, language, right? Well, now you got a math term translation, and it means to just move the figure. You can slide it around. And then we're going to talk about taking a figure and not making a mirror image, not sliding it around, but maybe spinning it, maybe turning it, rotating it, clockwise or counterclockwise. Yeah? Excuse you?
Is it possible to mirror it on the z-axis?
Is it possible to what?
To mirror it on the z-axis.
Translation. Taking a figure and just moving it, sliding it, right, left, up, down. Raise your hand if you have no idea what I'm talking about yet, because you're still not here yet. Are you here now?
Yeah.
What did we learn last week? What did we call it when we took a figure and we made a mirror image over it, and we were doing it over the y-axis or the x-axis? What's the R word? What did we do with that figure? It was a reflection. What are we doing today? What are we starting with? Starts with a T. Translating. We're just moving it. Go to the bottom of page 409. Each point in the trapezoid, the blue trapezoid, is going to move 6 right and 3 down. Look at it, study it for about 20 seconds. I mean, really try to understand what they're doing there, please. Bottom of 409. Look at the blue trapezoid on the left. It's in the second quadrant. And it's going to move to the right and down. Is it the same trapezoid? Yes. All they did was move it. How'd they move it? This should make sense to you. They took all of the points and they moved them exactly the same number of units to the right and the same number of units down. Listen, if you didn't move all the points the same units right and down, would it still have the same shape? You're not listening.
No.
Come on, focus. Look at the blue shape. If they did not move all of those points, how many vertices are in that trapezoid? 4. If they did not move all of those points, the same to the right and the same down, would it even be the same shape?
No.
No. So this should make total logical sense to you. If you're going to move a shape, you got to move all of its points the same. Right, down, up, left, whatever it is. We know that there's things called coordinates, x and y. X is always first, y is always second. They're ordered pairs. And so if we're going to move a figure, if we're going to translate it, if we're going to slide it right, left, up, down, we've got to move all the points the same. Either +6, -2, or -4, +3, whatever it is, they all have to be moved the same. Does that make perfect sense? I hope so. Please turn the page. In that one, they moved it, they added 6 to x and took 3 away from y. All right, how about rotation? What if we take a figure like the blue one It's in the second quadrant. And we're going to say, we're going to take that same triangle and go like this. We're just going to rotate it 90 degrees. Make sense? Do you see that it's 90 degrees first? It went from sitting up against the y-axis to sitting on top of the x-axis. That's 90 degrees. Raise your hand if you don't know that, or if you don't see that, or if you don't comprehend that that's 90 degrees from the y-axis down to the x-axis. That should make sense too. We rotated it 90 degrees. Which direction did we rotate it 90 degrees? Raise your hand. What direction did we go? Did we go clockwise or counterclockwise? We went clockwise. You're used to growing up in a digital age. 12 o'clock's here. Clockwise, 12, 1, 2, 3, right? Have you ever seen a clock with a face on it? Yep. I got to check and make sure. Okay? Clockwise, they went 90 degrees. Well, how did they do that? When you translate it, you understood. You got to move all the points the exact same, so that when you draw the lines again, it makes the same shape. You with me still? You with me, Elise? Monday morning. Okay, how about rotation? That can't be the same. So what's rotation do? There's a rule. Guess what? Math. There's another rule. Big green box, page 410. To rotate a point 90 degrees like they've done clockwise, you switch the coordinates, then multiply the new y by -1. Let's read that again, because when you first read it, you're like, what? Okay? How are your coordinates usually written? X, y, right? That's standard ordered pairs. If you're going to rotate a figure 90 degrees clockwise, you're going to switch the coordinates and multiply the new y by -1. Hello? Yeah. That should freak you out for a second. Yes. You're going to switch the coordinates and multiply the new y by -1. I'm sorry, the new y. Sorry. This would be the new y. You're going to switch them and multiply the new y by -1. Let's test it. What would the coordinates be for the A in the blue triangle? Raise your hand if you know it. No, up top. The blue triangle, what would the coordinates for A be? Jaden? -3, 3. Everybody see that? Come on, focus. It's -3, 3. According to this rule, what are going to be the new coordinates for A? Right now it's -3, 3. When we rotate it 90 degrees, what's the new coordinates going to be? We got to switch them. Noah. No, it's already -3, 3. No. Watch, Noah, watch. I'm going to switch these two. Watch this. 3, -3, but the new y has to be multiplied by -1. Oh. Come on, focus. Need your total focus. The blue triangle, top of page 410. It's -3, 3, the point A. We rotated 90 degrees by switching them. We went from 3 to -3, but wait, the new y has to be multiplied by -1. The new point's 3, 3, and what's the point A prime there? The red triangle, what's the coordinates of A? 3, 3. Try it again. What's the coordinates for C? On the blue triangle, raise your hand. What are C's coordinates? Someone besides Jaden. What's the coordinates for the point C, blue triangle?
0, 3.
0, 3. See if it works again. 0, 3. Switch the coordinates, and the new y's got to be multiplied by -1. Well, isn't it still 0? Okay. So when I walk back to that book, the red point C better be at 3, 0. 3, 0. Make sense? Are you looking at it? Point B. Right now, point B is at 0, 2. So what's its new coordinates going to be? It's going to be 2, 0 times -1, -0, 0. Right? Does everybody understand? To rotate something 90 degrees clockwise, switch the coordinates, multiply the new y, the second one, by -1. Uh-oh. What if you were to take that, what if you were to take a figure and you want to go 90 degrees counterclockwise? To rotate a point 90 degrees counterclockwise, switch the coordinates, and then multiply the first one, the new x, by -1. To go clockwise, switch them, make the second one, the new y, negative, or times -1. To go counterclockwise, switch them, multiply the first one by -1. Follow?
Yeah.
You sure?
Yeah.
What if we wanted to go 180 degrees? Top of page 411. A lot of stuff here this morning. Get you woken up on a Monday morning. What if you wanted to rotate something 180 degrees? In other words, it's going to turn upside down. You want it to be upside down. How's that work? Just to go 90 degrees, you switch them, multiply by -1. What if you want to go 180 degrees? Do you switch them? No. Listen, it's upside down. Think of it like this. It's straight up. I'm standing, feet on the ground, and if I go upside down, my feet are in the air, right? So I'm basically, I could be standing in the same place. I should show you my gymnastic ability by standing upside down right now against the wall. Nah. Anyway, I'd be in the opposite position, right? So all I'm going to do is take the coordinates, if I want to turn it upside down, and make them opposite. I don't switch them. I just make them opposite. It says multiply both coordinates by -1. Make them opposite. Does that make sense? Are you sure? Well, we're going to find out right now. Here we go. Number 1. We'll do as many as we can to make sure you're on the right path, and then I'll set you free for homework. What is the what's the transformation shown in number 1? Careful here. What is that transformation based on last week's knowledge and today's knowledge? What happened to the red or blue figure? Whether you went up or down, here, it's a reflection. Say amen if you see that that's a reflection. They reflected over the x-axis. Say amen if you understood that language. Thanks, Dean. I saw you. I know. I wasn't sure the first time. Next, number 2. What kind of transformation is that? David. Why?
Because that's what it means.
What'd they do?
They moved it.
Is it the same figure?
Yeah.
Same exact shape, right?
Yeah.
Has to be, doesn't it? And all they did was slide it. If you're the red one, going to the blue, up and to the right. And if you're blue going to red, down and to the left. What's number 3? Bella. She says it's a rotation, and she further explained it by saying it's a clockwise rotation. Raise your hand if you don't see that. Look at red and look at blue. Do you see clockwise rotation? Now look at blue and then look at red. Do you see counterclockwise rotation?
Yeah.
You sure?
Yeah.
Okay. Number 4. Oh, graph paper. You need some? I got some. You got graph paper?
No.
Oh,
I need some.
I know.
Alright, yeah. You know how you get out of being tired? No, I'm just saying you're not tired. That's all I do in the morning. I'm on my way to school, and if I'm tired in the morning, or if I'm tired, I just go, no, I'm not. I'm not kidding, it works. You just change your mind. No, I'm not. Anybody else need graph paper?
I love ice cream.
Pass that over to Brett. Rachel is the graph fairy. Okay, here we go. Number 4. Ladies and gentlemen. First of all, you have to graph RST on a piece of graph paper. Make yourself an X and Y axis. You'll notice that the numbers don't get too big. The largest they go is -5. So you don't have to use your whole graph paper to do this. Okay? So you're going to graph RST -2, 1. Make yourself a triangle. And then you're going to rotate it counterclockwise, which means switch them, multiply the first coordinate by -1. So let's see if I can try to duplicate a graph without lines to get close to what you have. I consider it a challenge. -2, -1. Go up there. -5, -2. Go up here. -4, 2. That's pretty bad. But am I close?
Yeah. Yes. Actually, wait, no. Kind of. It's a little bit. What is -4 positive?
Ah, no wonder.
Yeah, it's like really long and tall.
No, it's just a regular
Yeah,
positive.
it's way up there.
No.
And
How's that?
Hey, yeah.
Okay. -2, 1. -5, -2.
Wait, what?
See?
-4.
Oops, I did that way well.
-4, 2. Something like that. Okay. 90 degrees counterclockwise. I got to take all of my vertices, switch the coordinates, multiply the first one, because it's counterclockwise, by -1. So it's going to be 1, -2. Everybody follow?
Yep.
It's going to be 1, -2. 1. Then it's going to be 2, -5.
no, it would be -2.
Then it's going to be -2, -4. Right? Did I read those right?
That's not right. That can't be right though.
It has to be about 2 -4. Yeah, like that. I do -4.
Yeah, you're right.
The next one's got to be -2, -4.
I thought it needed to be a triangle.
I don't think I got it right.
It looks nothing like it.
That probably didn't.
Shut up. Shut your mouth.
Okay.
Right now. Right now.
Wait,
Who's talking like that?
It's that kid.
Like
Wow.
He was bullying me.
No, it looks like this.
Look, 90 degrees from here, counterclockwise to there, to there, to there.
Oh.
I was in more heat than mine.
So like you like switch
To go 90 degrees, both cases, counterclockwise or clockwise, you switch the coordinates. Counterclockwise, multiply the first one by -1. Clockwise, multiply the second one by -1.
Wait, I'm confused. Okay, so like you switch them, you always switch them first? Okay.
For 90 degrees.
Yeah, okay. And then since we did counterclockwise, we get the first one by -1?
Yes, after you switch them.
Oh, we're doing counterclockwise. That's why. Okay. That's what's the one? Okay, next turn.
Turn the page.
Wait, I know.
You'll get more practice. Number 5. What kind of transformation is number 5? Raise your hand. What kind of transformation is number 5? Dominic. Reflection.
Well, why is there no big candy line?
How's that a
It's not. Is it?
Where?
I shall prove this wrong. I shall prove it wrong.
The left,
Oh, in the middle. In the middle.
oh, the left and right are exactly the same.
Yeah, if you cut it down the middle.
Right.
Vertically.
Look, you take a line of symmetry and you go right down the middle from top to bottom. They're reflections of each other. Next. Number 6. What kind of transformation? It's rotation and it is 180. 180 degree rotation in number 6. Number 6, stop the chatter. Number 6 is rotation. Anybody out there not know or see that 5 is reflection and 6 is rotation? Speak now. David, what do you not see? Okay, number 5, David. Imagine taking a line from the top to bottom, right down the middle, a line of symmetry. The left and right side of that are going to look exactly the same. Okay, number 6 is a rotation. It's rotating. You see it? Well, then why are you saying you didn't?
If you were to like cut it right down the middle, you know how to flip it to the back. Wait, what's rotation? Number 6. Number 6.
6 is rotation, bud.
6. Oh, rotation. Yes.
Okay. Number 7. If you're going down an escalator, what kind of transformation is happening to you?
Go down. Down.
You're what? No. You're just going down an escalator. Here you're standing. You're go ahead. Go ahead. Translation. You were here, and now you're the same person, and you've slid down the escalator, and now you're there. You've changed position. Your position has been transformed. You're not laying down at the bottom of the escalator. Next. Number 8. Passing food around the table. Rotation. Making a handprint in clay or cement. Reflection. Number 10. Playing checkers.
Translation.
They're all transformations.
Translation.
Isaac, translation. Because you're sliding the checkers over the board. Please stop the chatter. Number 11. Opening a combination lock. Rotation. You turn it, right? 12. Going down a water slide. Kara. Translation. Number 13. Riding a carousel. You might know it as a merry-go-round. Rotation. And finally, looking in a mirror. Reflection. Your homework.
Thank you.
15 through 18. Go.
We got these graph paper.
Of course.
I'm just like,
Test Thursday. Thursday. End of the quarter is Friday.
You're making me more nervous.
Thursday. We'll review tomorrow and Wednesday. That's why it's not till Thursday. It's not, Kara. Kara, that's why it's not tomorrow, dear. Kara, when do you want the test? June?
Friday. No, I want it next Monday.
Oh, after the quarter's over. Why? Are you hovering?
Are you trying to
Do you have an A right now, Kara? Oh.
no, it's
What's
Thursday.
18?
My leg is
Better speak positive, girl.
What is the number?
I'm saying that right.
13, 14.
Okay, I'm studying science, so I'm gonna have homework.
15 through 18. Ladies and gentlemen, when you hear my voice, please stop talking. You do know that 17 and 18, you don't have to use graph paper, right?
Oh.
How?
It just says find the vertices.
Oh, I know what you mean.
Did I not cover vertices at the beginning of the lesson? I said, does everybody understand that a trapezoid has 4 vertices? The points where you put the coordinates. 15 through 18 on 412. Test Thursday.
Yay.
We'll review, God bless you, Tuesday and Wednesday. Hopefully you have outdoor activities planned today, like baseball.
I went on a 3-hour. I'm doing
In the
yoga
60s.
today. So, active.